Good day, welcome back to our channel. I'm Maile Matsiba. We're continuing with our 2017 study guide and we're looking at example 5.1.3. It says a 30% solution of Na2CO3 in water is made by dissolving crystals of Na2CO3 10H2O in a 10% solution of Na2CO3 in water. What mass of crystals must be dissolved in 100 kilograms of the 10% solution to achieve the required 30% Na2CO3 in the final solution? So there's actually a diagram there. So as always, let's choose a basis. So the basis we're going to use is actually the 100 kilograms of the 10% solution, and this is actually the stream. So we're going to say basis equals to 100 kilograms of 10% Na2CO3 solution. That is our basis. And with that said, I just want us to define these other two streams. So it's always easy to name the stream X because we don't know how much of this is there, and I want us to name this one Y. So this is X and this is Y. So in our calculation, we're going to calculate both of them. It's going to make it easy for us when we make equations. So let me just write there that let X be the amount in kilograms. Let X be the amount in kilograms of Na2CO3 10H2O, and Y be the amount in kilograms of the 30% Na2CO3 solution. Yeah, so we have defined our two streams as X and Y, and we already know that this is actually 100 kilograms. So yeah, so we need to calculate this and that. Remember, the question says how much. It says what mass of the crystals must be dissolved in 100 kilograms of 10% solution to achieve the 30% solution. How much of this must be added in the 100 kilograms to be able to achieve the 30% solution of Na2CO3? So that is actually the approach. So our step one would be we need to calculate the mass fractions of both Na2CO3 and H2O in this stream here. So yeah, so we say calculate the mass fractions of Na2CO3 and H2O in Na2CO3 10H2O. That's going to be our first step. We need the mass fraction there. We don't know how much it is, but we actually can calculate the mass fractions. Remember, here we have the mass fractions. We have 10% here, we have 30% there. We can actually easily get the mass fractions, but here we don't. So with that said, we're going to say, therefore, the mass fraction Na2CO3 equals to, okay, let me just write in brackets that in Na2CO3 dot 10H2O, yeah, is equals to the mole mass Na2CO3 all over the mole mass Na2CO3 plus the mole mass mole mass H2O. So the mass fraction of Na2CO3 in here is actually the mole mass of Na2CO3 all over the mole mass of everything. And in calculating that, we can easily say we know the mole mass of this one is actually 106. If you calculate the mole mass of Na2CO3 using the periodic table, you get that it's 106. Then we just write it kilograms per kilomole all over 106 kilograms per kilomole plus the mole mass of water. But remember, the water here, it's not just H2O, it's actually 10 times that, so it becomes 18 by 10 becomes 180 kilograms per kilomole. Yeah, let me just put this properly. Yeah, equals to, when you do that, you will get, let me just say, 106 kilograms per kilomole all over 286 kilograms, oh no, space, kilograms per kilomole. And with this falling off, it will give you 0.37069. This is actually the mass fraction of Na2CO3 in these crystals here. And we go further to calculate the mass fraction of water. Remember, we calculated the mass fraction of Na2CO3. Now we need to calculate the mass fraction of the water. So we say mass fraction H2O equals to, let me write again, that in Na2CO3, yeah, it's equals to, we know that the mole mass of, we know the mole mass already, we know the mole mass of H2O is actually 180. It's H2O by 10 is 180 kilogram per kilomole, so it's equals to 180 kilograms per kilomole all over. We know that the total mole mass is 286 all over 286 kilograms per kilomole. And if you actually use a calculator, you will get 0.629371. So now we have the mole mass of both Na2CO3 and H2O in the stream. And yeah, with that said, it takes us to our step 2. Step 2, we say calculate X and Y. So this is it. So we're now calculating this, and remember, we have the streams. We might not have all the information, but we have the mass fraction of this stream and this stream and this stream. So we can actually make 2 equations out of these 3 streams, and then make sure that we calculate Y. Remember, what we want is actually X, but Y is going to help us to create the equation that would help us calculate X. But what we want is X. Remember, the question says what mass of the crystals must be dissolved? How much of this must be dissolved in this so that we can reach 30% Na2CO3 solution? So with that said, we're going to say Na2CO3 balance, right? So when we do an Na2CO3 balance, we know we're going to be saying, let me bring it here. From here, we're going to be saying 0.37069 0.062 plus 0.1 by 100 kilograms equals to 0.3y. That becomes our first question, our first equation rather. Remember, here we know that the mass fraction of NaHCO3 we calculated to be 0.37062. Here is 10%, so it's 0.1, and here is 30%, is 0.3. So 0.3, that's where the equation comes. 0.37x plus 0.1 by this, by 100, plus 0.3 by y. So we actually did an Na2CO3 balance, and we got that equation. So we are saying all the Na2CO3 in here plus all the Na2CO3 in here is equals to all the Na2CO3 in here. That is the whole concept around the equation. And now we can also simplify the equation to say is 0.37062 plus 10, because when you simplify this, right, is equals to 0.3y, right? Now with that said, we can now do, after we do that, we're going to be doing the mass balance of the whole system. We'll do the mass balance of the whole system. We know this plus this equals to that, so we'll say x plus, or let me just write it down, mass balance of whole system. Now we are doing the mass balance of the whole system, right? We know that in the whole system, the mass in here plus the mass in here equals to the mass in there. So therefore, x plus 100 equals to y, right? And that is our equation 2. And with that said, we can actually substitute 2 in 1. We can substitute this one in here. Remember, we know y equals to 100, x plus 100. So with that said, we can have therefore 0.37062 9x plus 10 equals to 0.3 x plus 100. So that's how it goes. And if you actually simplify everything else, you can reach, it's 0.37062 9x minus 0.3x equals to 30 minus 10. Therefore, when you do that simplification, you get 0.07062 equals to 20. And therefore, when you simplify the x, this is x, right? Therefore, x equals to 20 over 0.070629, and it's equals to 283.170. Therefore, Na2CO3.10H2O equals to 283.2 kilograms. So that's actually how to solve it. Now that we've calculated the x here, we know full well that then that means our Na2CO3 10H2O equals to 283.2 kilograms. So yeah, that's what it is, and thank you for your time. That's actually how to solve this question. Thank you for your time, and let's meet again in our next video.